Today, we stand on the brink of a whole new world of medical science, one known as regenerative medicine. Throughout the centuries, advances in medical science have often been met with skepticism. Medical procedures such as blood transfusions, vaccinations, birth control, surgical sterilization, in vitro fertilization, and organ transplantation were initially rejected by some. All of these techniques have become universally accepted and essential to daily medical practice. Now, with this potential breakthrough of regenerative medicine, doctors may actually be able to cure diseases, not just treat them with pills and shots. Insulin-producing cells may, very soon, be used to cure diabetes. Retinal cells could potentially make the blind see. Quadriplegics may walk again. Stem cell research may have the ability to cure over 130 million Americans plagued by chronic, degenerative diseases and conditions. This is the potential that stem cell research holds for us. What are stem cells? Stem cells are the basic building blocks of our bodies, with the unique ability to turn into cells that make up our tissues, bones, and organs. Stem cells have the potential to replace cell tissue that has been damaged or destroyed by severe illness or injury. The National Institutes of Health and the National Academy of Sciences, the two premier science arms of the government, call stem cells the internal repair system for the body. In addition to their future therapeutic use, stem cells already help scientists understand the causes of incurable diseases and conditions in order to prevent, treat, and cure them. Regenerative medicine will focus on two types of stem cells: adult stem cells and early or embryonic stem cells. The term adult does not mean that these cells are from adults, but rather they are cells that are committed or programmed to become a specific type of cell, such as a blood cell, skin cell, or any of the over 200 different cell lines of the human body. The term embryonic, on the other hand, refers to more potent cells that have not yet been committed or programmed to become any particular type of cell. So, they have the potential to become any cell of the human body. What makes early or embryonic stem cells different from adult stem cells? Adult stem cells have been studied for over 40 years and have been used to successfully treat diseases of the blood, such as leukemia and lymphomas. In the few short years since the discovery of early or embryonic human stem cells, researchers have successfully demonstrated, in animal models, the even greater potential of these more potent stem cells to reverse incurable diseases and conditions in animals. Researchers are studying embryonic stem cells to learn how to make adult stem cells more useful, but mainstream science is in agreement that early or embryonic stem cells, the only cells with a capacity to become any cell type of the human body, have much greater potential than adult stem cells.
Adult stem cells are extremely useful in medicine. We've known that since the mid-1970s, the great work that was done in the cancer field. Adult stem cells have been around for quite a long time, and they're extremely useful. And we certainly want that research as well as that clinical application to continue. However, we all know that adult stem cells are limited in what they can do. Embryonic stem cells are much more useful and less of a problem when it comes to immune rejection.
Early or embryonic human stem cells presently come from two sources. First, they may be produced from leftover fertilized eggs from in vitro fertilization clinics, where they would otherwise be discarded. Or, secondly, they may potentially be made from a laboratory procedure called somatic cell nuclear transfer, or SCNT. When couples undergo in vitro fertilization treatments, more fertilized eggs are produced than are needed. The surplus fertilized eggs are frozen for one of three purposes: for possible future use by the couple, for donation to other infertile couples, or for medical research. The remaining eggs will ultimately be discarded as medical waste. It is estimated that there are currently over 400,000 frozen fertilized eggs at in vitro fertilization clinics, many of which will ultimately be thrown out. Instead of being flushed down the drain, these cells can be used for stem cell research that has the potential to save countless lives. How are stem cells derived from an IVF fertilized egg? After about 5 days in a petri dish where the fertilized egg has been dividing, a small clump of cells, the stem cells, form in the inner cell mass of the developing cell mass, now called a blastocyst. These cells are undifferentiated, meaning there are no organs, and the cells still have the potential to become any cell type in the body. These cells are placed in culture and may be directed into specialized cell types that can potentially be used to treat patients or to study the underlying causes of diseases. The second source for early or embryonic stem cells is a laboratory procedure still unproven in humans called somatic cell nuclear transfer, SCNT, which begins with the patient and ends with the patient. What is SCNT? SCNT provides a unique opportunity to grow a patient's own cells for repairing or replacing his or her diseased cells. With SCNT, the nucleus containing the DNA would be removed from the patient's somatic cell, such as skin or blood cells. The nucleus containing the patient's DNA would then be transferred into an empty, unfertilized donor egg that has had the